First of all, for those who didn't come to the tutorial, I say to you, there's only 3 students here on a sunny afternoon. Those 3 students, I guarantee, are going to get better marks than any of you who didn't bother showing it. But I have an excuse. I had to work. It's sunny. Ah, shut up. I couldn't care less. And I gave them all candies, too. So there. Now, sorry, but they're all looking at me like, what are you yelling at your computer for, Mr. Dewick? I'm not yelling at the computer. I'm yelling at the people in the internet who didn't come to my tutorial. Questions from the review that you're going, holy schmoly, I have no idea how the heck to do them. Now is your chance to ask. Don't hesitate. Call them out.
Number 9.
Number 9. I'd love to do number 9. I will start out by asking, did you look at my online solution key? Because I will say, if you haven't actually looked at this, you've missed out on the chance to figure it out yourself. So I'm going to start out by just putting number 9 right here temporarily. First, I'm going to go like this. Come here, Mr. Duke. I'm not in mid-season form yet. Click, click, clip. Number 9. See, this is what I can do. I paste this in here, and so whatever questions you ask, I can print up at the end, and you get them to take home with you. Did you look at my online solution key? Be honest.
No.
Okay. Next time you should. I will do it because I've had about 5 kids ask me about it. And I think I said I like this question. Specifically, what I like about this question is it asks you to find a velocity of a projectile after a certain time. And I'm just, there we go. So a projectile is launched over level ground at 35 meters per second at an angle of 24% above the horizontal. As soon as 24%, 24 degrees. As soon as I see that, I'm going components right away. Yes? If I were to DALP, my initial launch would look something like that. I'm pretty sure that you'll find that Vx ends up being 35 cos 24. Am I going too fast if I skip that? If I just go straight to this, is that okay? Because we're pressed for time. And you're going to find that Vy initial ends up being 35 sine 24. You end up with 35 cos 24. 31.974 and 14.236 meters per second. Okay. I don't seem to have much room. Now, because they're talking about time of flight, and I know I'm going to have to solve this vertically, normally I would write horizontal and vertical. I'm going to run out of room. I know this already, so I'm just going to do the vertical column here. Vertical. I know that. I know this. Yes? By the way, I do know 2 more things. I know this. How high was I when I started? How high was I when I started? Give you a hint. How high was I when I started? 0. How high am I when I finished? 0. What's my displacement vertically then? 0. Have I traveled horizontally? Yeah, but that's not what I'm at. I'm saying my vertical displacement, I didn't go anywhere. So I could use that. And I do know Vy final, because if I'm starting and ending on the same height, I can use what goes up must come down. I know Vy final is negative 14.236. I left the ground going up at 14.236. I'm coming back down at 14.236. How do I show down? Negative. I think I would choose to use T equals Vf minus Vi all over A. Now, there's a third way you could have done this. You could have said V final is 0 at the top, find time to top, and doubled it. I like this method because it gets me there in one fell swoop, and it's not that big a stretch for me to say, well, I know V final is negative V initial if I'm starting and ending on the same height. When you crunch the numbers, negative 14.236 minus 14.236, close bracket, divided by negative 9.8. You get a time of 2.905. 2.91 seconds. I'll go to 3 sig figs because A did want the time of flight. How long is it in the air for? It's not meant to be a trick question. How long is it in the air for? Say it louder.
2.917.
B. What will it look like after 2.5 seconds? I'm telling you right now, it's on the way down. You know how I know it's on the way down? How long was it in the air for? 2.9. You know what? 2.5, it's on the way down. In fact, it's almost at the ground. Because B asks, what's the velocity, magnitude, and direction? Because I figured out the time in the first part, I know that if I draw it, that's the velocity. See, that's how I knew how to draw it downwards and not upwards. Oh, and that's made up of that and that. It's made up of 31.974. Now the mistake, the common mistake I see kids make is they do this. Don't write this down. That's V final after 2.9 seconds. Don't you be using that. Or they put V initial vertical there. No, 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 no. We have a new time. What's the time in this question? 2.5 seconds. You know what? We are going to have to find Vy after 2.5 seconds, which is going to be, well, I know Ay is negative 9.8. I know T is 2.5 seconds. And I know that Vy initial was 14.236. Vy final, just before, well, right at 2.5 seconds, is going to be 14.236 plus negative 9.8 T. Vi plus AT. Right? I would write the formula if I had time, but I'm pressed for time. Gosh, I'm going to have to cut this string off on this thing. 14.236 plus negative 9.8 times 2.5. Did I get a negative velocity? What's that telling me? It's on the way. Did I know that already? Woohoo! I'm right. You know, got a little built-in kind of confirmation. I'm pretty sure I'm good. 10.264. Now, I'm not going to put the negative on here. It's implied in the arrow, but I'm going to put the 10.264 on here, and I want to find V. We're going to use Pythagoras. Darn right. V squared equals 974 squared plus 10.264 squared. The magnitude of the velocity is going to be that number squared plus 31.974 squared, square root, 33.6 meters per second. That's the magnitude. Did they also ask for the direction? At, there's theta. Which trig function? As usual, it's tangent. $17.8. And we would call this direction below the horizontal, not south of east. If we were looking at a map and looking down at the world, then it would be south of east. Let me double check, are we right? Woohoo! 33.6 meters per second, 18 degrees. That's to 2 sig figs below the horizontal. Okay. What do I like about that question? B specifically. Somewhere I'm going to ask you to find the velocity. In fact, you know where you're going to end up finding the velocity? You're going to end up finding the velocity in the question. That's the last question on this unit review that I told you was going to be on your test. Except there, you're going to have to go one extra step. They're not going to give you the time. You have to find the time first. And then you're going to be heading downwards into the wall, and you have to go Vx, find Vy final at the time that you calculated from that question, and then away you go. Next.
Can we do 25?
25? Love to. Did you try looking at my answer key on number 25?
Yeah, I looked at it.
You did, actually? Or are you lying to me?
I looked at it.
Good.
Grab shots.
25. Horizontally, off a cliff. Actually, which means probably it's going to be a little easier. There's something's going to be a 0. Clip. Mike runs horizontally off of a cliff. Certainly isn't Graydon because he can't run at all. Okay. Oh, sorry. Normally I would say Dulp. Did they for me already?
Yeah.
Yeah. And also, take a look at this question. They gave you a displacement in the diagram. The displacement that they gave you, horizontal or vertical? Look at the picture. I'll be solving this horizontally when I do my horizontal vertical, which means actually this is going to be a little easier, I think. Let's see. I don't need to go components because horizontally I already got components. Here we go. Horizontal, vertical, AX equals 0, AY equals negative 9.8. Vx equals 6.5. Vy initial is nothing, right? And now I'm going to scroll down. Dx is 15. What do they want me to find in part A? So I'm going to write T equals, it's going to be the same time vertically as horizontally. Which column do I know 3 things in? Yeah, the horizontal. I'm looking for an equation that has A, Vx, D, and T in it. I think D equals Vit plus a half AT squared. I think D equals Vxt. Do I need to write the plus a half AT squared if I'm doing this horizontally? I say to you, no, because there is no AX. Get the T by itself, Graydon. It's going to be 15 over 6.5. Time of flight to hit the water. It's going to be 15 over 6.5. 2.307692308. 2.31. And I usually put a box around it if it's if it's the final answer, just so it stands out. What do they want in part B? How high? I'm willing to bet we're going to use T now in the vertical column and work our way backwards and find dy. I betcha, I betcha, I betcha. Let's see. So, vertically, I already said AY was negative 9.8. I said that VY initial was 0. Oh, I know time, 2.31. They want that. Have I got an equation with A, VI, T, and D in it? Conveniently, that's going to vanish. It's going to be 0.5 times negative 9.8 times 2.31 squared. This really shouldn't be worth 4 marks. I think the first question should be worth 4 because you're doing a little bit more math and thinking. I think the second question should be worth 3. I get negative 26.1. That's because I end up 26.1 meters below from where I started. But technically a height is a scalar, so I'm going to write 26.1 meters. Am I right? What number was that? 25. Let's go see if I was right. 2.31 seconds. 26.1 meters. Woohoo! I like that. Now, what made this question a little easier? The fact that they gave you a horizontal displacement. Okay. If they gave you time, that really makes it easy. But using dx to find time, sure, that's fair game. Is that all right? Next! Sorry, what?
I don't have a question. I'm looking at a scholarship question right now.
Okay. Do you want me to walk you through the scholarship question? Because it's nerdily delicious.
Sure.
It's cool. It's both harder and easier than you think. Okay? The first part of that I said is a no-brainer. I see an angle, don't you? I went components. I said Vy is 12.7, Vx is 14.12. Ah! But the balloon is also traveling upwards vertically. That's going to add this 3.5 right here to the vertical. That's why I wrote down now, add 3.5 to Vy. That's your initial vertical velocity. And now, Brian, you can just freeze time for a split second and simply say, this is exactly like launching from a standstill cliff with an initial horizontal velocity of 14.12 and an initial vertical velocity of 16.12. Now it's a cliff question. Because now you'll see when they said, what's the range? When I did this answer key, I hadn't gotten into my habit of putting a big H and a big V and drawing a line down the middle and separating it. But you'll see I said, here's Vy, here's Ay, dy, negative 25 below, need T. I wrote it out, use the quadratic formula, or you could have found the V final and then backtracked your way and found T. Make sure Vy final is negative. And I got a time of 4.45 seconds. The range is dx equals vxt. Vx was 14.12.
Why did you add that 3.5 to Vy? I just don't get it.
Read this sentence right there.
It's traveling upwards at a constant velocity.
Of what?
3.5.
What does the word upwards mean? What direction? Or did you just point vertical? So are you saying that when we launch this balloon, when we launch this projectile, since it's already moving upwards, I better add that 3.5 to that vertical component right there? Because really it's traveling upwards not at 12.7, but at 16.2. It's got a 3.5 meter head start when we launch it. 3.5 meter per second vertical head start when we launch it. Think about it, you're doing this. And then launching. Oh, you got to include that little bit going in. If you see that, then the question falls apart. The rest of the question is Physics 12, not scholarship. This first thing right here, to me, is the scholarship concept. And the fact that it's scary. Oh, you got a balloon moving. Yeah. Freeze time for a split second and just realize that you're already moving up at 3.5 meters per second, so you better add that to your vertical velocity. In fact, as a nasty question, what if you were falling at 3.5 meters per second? Well, then you would take that 12.7, you would subtract 3.5 from it. That would be your net vertical velocity, but now you would then walk through all the same stuff, vertical and horizontal. Yeah. Pardon me? Most of the scholarship ones, if you see it right, they're longer, not tougher. It's almost always combining several different concepts. The nerd within me likes them. I always enjoyed doing these. Any others? Sorry. Especially with the answer keys being online that you can look at. The only thing I wish is, when I made these up, I hadn't started doing screencasts. Otherwise, what I would do is I would have made the answer key up while talking through each question and put a video online for YouTube as well. Well, shut up. You're getting more than you're getting with most teachers in the province. I don't know if you're a lot more. There's other teachers that are starting to do what I'm doing. Have any of you watched any of the videos yet?
Yeah, I've watched one.
I've been told by the kids they help. So.
I watched one. No. Last year.
Yeah.
The detailed answer keys help the most because it's not just the formula,
Yeah.
the numbers. It says you need this.
And you'll find, especially often, I write little notes. You'll see me. Aha! I need this. Dope. Couldn't find this. Better try that. I tried to let you into my frightening brain. Ah! Well, you know, I tried to show you what I was thinking as I was attempting these. Any others? Okay. Going once. Going twice. Okay, I'm going to pause the video.